Hey guys, and welcome back to another video on the channel. In today's video we're going to be looking at the physics paper 1 for the QCAA syllabus 2020 paper. This is the multiple choice. Okay, so this one here is from the Queensland syllabus in Australia. And this one you'll be probably needing this physics formula sheet here pretty much, okay? So these constants are slightly different, but it's still just a general physics test just from 2020, okay? This one's comprised of 20 multiple choice and each of them are worth 1 mark. I think we've already done the short response. I'm pretty sure it's up on the channel, just following up with pretty much the multiple choice questions, okay? Now, if you have any questions at all throughout the video, leave a timestamp and pretty much ask what question you need to ask on a certain question if you're not sure. Or if you think I've made a mistake, just still leave a timestamp and I'll try my best to answer it, okay? But otherwise, I'm just going to get straight into the video, okay? So, question 1. Now, this one here I actually got wrong at first, and I realized my mistake. So here. Which of the diagrams correctly represents the forces acting on an object resting on an inclined plane? So here we're given 4 different diagrams. Now with the inclined plane, straight away to work out ones that are incorrect, you've got to see if they all have a force due to gravity. So if an object's on an inclined plane, force due to gravity will act straight down regardless of pretty much where it is on the surface. Okay, so it'll go straight downwards. So here, diagram A, the thing is going like that, so it's not acting straight down, so this one is incorrect. And also, which one is also incorrect? C is also incorrect, so here it doesn't act straight down, it goes like that, okay? So it can't be A or C. Now, a lot of students end up picking D. Now the reason why they pick D is because they think, alright, that force counteracts that force, therefore it doesn't move, okay? Because they strictly think of horizontal movement. However, they're not accounting for the vector component from this guy here. So this downward component will have a sideways component and a downward component. Now this component is acting opposite to this one here. However, this one here is an additional horizontal component. So imagine this blue vector getting added with this one here. That is going to force it to go this way because there's more force going down the slope. So while that might counteract that, it's not accounting for this additional vector here. So D is actually incorrect. The reason why B is incorrect is because this component here is actually cancelling out that component there. So while this one looks incorrect, it's actually the correct answer because it's perfectly balanced. Horizontal forces are balanced and vertical forces are balanced, okay? So the correct answer is B, okay? If you have any questions about this one here, leave a timestamp or pretty much any question, just saying question 1. And I'll try my best to answer it because it is a tricky one at first and I got it wrong. I put D. It took me a bit to realize why it was B though, okay? So let's head on straight to the next one. So question 2 is a definition question. The definition of the average speed is the rate of change of. Now straight away, speed, you've got to know the difference between speed and velocity. Speed is distance on time. Velocity is displacement on time, okay? Now here they've put velocity and they put acceleration. Those have nothing to do with the rate of change, what speed is, okay? Speed is going to be distance on time, okay? So I better put speed here, okay? So here, distance is the correct answer. They've put displacement because you've got to know the difference between the two of them. So that would be velocity is displacement on time, but speed is distance on time. So the correct answer is B, okay? And that's just the definitions question, okay? Right, question 3. The diagram shows 2 vectors, vector A 12 kilometers to the east and vector B 9 kilometers to the south. Calculate the magnitude of the resulting vector when vector A is added to vector B. So here, when we're adding vectors, whether it's in physics or mathematics, we add them head to tail. Now this is the tail of a vector and this is the head of a vector. The head of the vector is going to be where the arrow is pointing, okay? So here that would be the head and that would be the tail. So here if you add head to tail, you can draw it, so vector A added with vector B could look like this, or it could look like, what would the other one be? Something like this. No, actually no, that one's down. So I'm just trying to draw the other one. Down, and then that's the same one. There is another one. Yeah, there we go. So you can draw it like this, or you can draw it like this, okay? These vectors here will be the exact same. So this is the exact same vector as that one there, okay? So you can draw them 2 different ways. So here, this side length, this is vector A, so that's 12 kilometers. This is vector B, so that is 9 kilometers. So to find the length of this guy here, we've got two components, but you can treat that as a right angle. So all we're doing is finding the hypotenuse of a right angle triangle. So here, this guy here would be the square root of 12 squared plus 9 squared, all square rooted, okay? Chuck that in your calculator, and that will print off 15, okay? So the correct answer is 15, okay? So that's 15 kilometers going going along A and then B. That direct vector there is just 15 kilometers, okay? Righto, let's move on to question 4. So the diagram shows a current carrying loop moving from one magnetic field to another field in 0.6 seconds, okay? So here we can see we have a very strong magnetic field moving to a weaker magnetic field, because you can see all these X's. These X's represent the magnetic field line, so it's going from a strong to a weak. So what we're going to be doing is pretty much working out, all right, what's changing here is pretty much the magnetic field. The area of this object isn't changing, okay? So here, calculate the EMF produced in the carrying loop. Now, the way we calculate is using this formula here from electromagnetism. Your EMF is the number of loops, change in flux over the change in time, okay? Now, all we need to know is, well, there is only one loop here, so we can just say your EMF. Now, the negative sign doesn't really mean anything. It just means pretty much voltage, okay? So here you could probably get rid of that and just go change in flux on change in time. So EMF will be change in flux over the change in time, okay? Now here your change in time is this guy here. So that's how many seconds? So your change in T is 0.6 seconds, okay? Now your change in flux. Flux is your magnetic field strength times your area. Now if you look here, your circle is not going to shrink. It's just going to a weaker magnetic field. So your change in flux is strictly due to the change in your magnetic field. So you change your magnetic field times your area. Now the area of this is going to be a circle. Now notice here it's in centimeters. You need to put in SI units. So here, go centimeters to meters. So it's going to be 4 divided by 100. So here, your radius is going to be 4 over 100. And you can just pretty much just put it straight away if you wanted to as just 0.04. A lot of people lose marks by not converting that. So that's your radius. Area of a circle, remember from year 10 mathematics, pi r squared. Everyone should be able to remember that, okay? So area will be pi, 0.04 squared, and I'll just work out what this number is. Pi times 0.04 all squared. So that will give you 5.0, I'll just round it to 3, times 10 to the negative 3 meters squared. Okay, so that's the area of this circle. Now the change in magnetic field strength, it's going from 3. Now here we've got to work out what that prefix means, because this doesn't mean just 3 Tesla. This might mean micro or milli. Okay, so go to your sheet, pretty much check your prefixes here. Now if you see here, oh, it's milli. So milli 10 to the negative 3. Okay, so what this means is 3 mt. This means 3 times 10 to the negative 3 Tesla. Okay, and this here means 1.5 times 10 to the negative 3 Tesla. Now you can see here the change in field is quite obvious. You're just going to go this, subtract that, okay? So field 1 minus field 2, so 3 times 10 to the negative 3 minus 1.5 times 10 to the negative 3, and this will give you your change in flux. So literally you can just go 3 minus 1.5 because that's the same. So here they'll give you 1.5 times 10 to the negative 3. Now that is your change in magnetic field strength, okay? So that is going to represent that there. This one here is representing your area, so you can actually work out what your change in flux is. So here your change in flux will just be 1.5 times 10 to the negative 3 times by the area, so 5.03 times 10 to the negative 3. Now this is not your answer because we're after an EMF. This is just your change in flux, okay? So 1.5 times 10 to the negative 3 times by 5.03 times 10 to the negative 3. Is it 10 to the negative 3? Yep. So here, change in flux, 7.545 times 10 to the negative 6 Weber. Okay, now you can put Weber, but it doesn't really matter here. So EMF will be 7.545 times 10 to the negative 6, because that's your change in flux. And then divide that by the change in time, which we got given up here as 0.6. So go this number, but divide that. So go shift answer, divide by 0.6. So this will give us 1.25 times 10 to the negative 5. Okay. So here, we're just going to say, all right, which one of those matches? Now here, all these numbers are roughly the same. Now my number is not exactly perfect, but it's pretty damn close to all these numbers here. So here we can just ignore it. We're just looking at the scientific notation. Minus 10 to the negative 5. Just look for the 10 to the negative 5. So my answer is B, and that's the correct answer, okay? This one here is a lot of working for 1 mark. So if you're getting really stuck on this one, move on and go to the next question, because it's not worth it if you're just doing all this work and get it wrong and just lose 1 mark, okay? Because it's time wasted, okay? Let's go to question 5. Which of the following is Lenz's law? So Lenz's law is pretty much if you move a magnet through a coil, the change in flux will produce an induced magnetic field that will oppose the change in flux. So we've got to look for something around those lines here, okay? A, the total electrical charge in isolation system, blah, blah, blah. That's not Lenz's law, okay? So no magnetism at all was there. B, magnetic flux around a carrying wire produces a proportional rate of the current. That looks promising, perhaps. Now here, the direction of an induced electric field always opposes the change in the circuit or magnetic field. Nope, that's definitely not it, because that mentioned electric current. Oh wait. The direction of an induced electric current always opposes the change in the circuit. No, actually that could be it. I'll have to double check what I put. So we'll put a question mark there, just because we've just got to break these definitions apart. The ratio of sines angle, okay, that's definitely not it. That's like Snell's law, okay? So it's between B and C. Now, let's take a look at what they're actually saying. The magnetic flux around a current carrying wire is proportional to the rate of change of current. That's talking about a formula, okay? So here, magnetic flux in a current carrying wire is proportional to the rate of change of the current. I don't think that's it, okay? C, the direction of an induced electron current. So if a magnet goes through a coil, it will produce an electric current that goes around like this, depending on which is north and south. They will always oppose the change in the circuit or magnetic field that it produces. So they've mentioned magnetic field it produces. So here I think the answer is C. I'll double check what I put. Yep, the answer is C. Okay. So here I was looking mostly for a change in magnetic field and the word oppose. Okay. So here they've mentioned proportional. That's talking about a formula. But Lenz's law is basically saying it will oppose the change in magnetic flux. Now here they've said opposes the change in the circuit or magnetic field that it produces. It isn't perfect, but it's the best one given these 4 here, so you have to put that one. Okay? Right, let's take a look at 6. Relativistic momentum. That's talking about this one here. So this is from special relativity. So let's just see which one's talking about that. The momentum of object when measured in Newtonian frame of reference. Newtonian frame of reference doesn't account for special relativity, so that can't be it, okay? Momentum of an object when measured regardless of the frame of reference. That's not talking about special relativity. That's basically saying all frames of reference are the same. The momentum of an object measured in a frame of reference when the object is in motion. So this means it's traveling with the object, which is true, okay? Because if you were looking at it as a observer, so if you weren't traveling with the object, you would just measure the momentum as mass times velocity. But if you're with the object, you're measuring the momentum like this. So that is actually spot on. But let's read the next one as well. Momentum of object when measured in the frame of reference in which the object is stationary. Nope, that's this one here. So the correct answer is C. Okay. Any questions about that one? Leave it in the comments. Okay. All right. Question 7. A quantum of any form of electromagnetic radiation is also known as, okay, so an electron is not electromagnetic radiation, okay? A positron is the opposite of electron, it's not that either. An X-ray could be it, but its general name is known as a photon. So electromagnetic radiation is another word for light, and light is also called a photon. So the correct answer is A. An X-ray is talking about something else, okay? It's not, if it's between these two, it's a photon, okay? Right, question 8. An object 46 meters above the ground is projected horizontally with an initial velocity of 25 meters per second. Calculate the horizontal displacement. So here, velocity, so mu x is 25 meters per second, and sy is 46 meters. So here, with projectile motion, you've got to split up horizontal motion and vertical motion. So vertical motion, the initial velocity is 0 because it's getting projected horizontally, so it's going to immediately drop. So u of y would be 0 meters per second. Now, gravity is acting. It's going to go downwards. So here we can just say gravity is positive, okay? Because it's going in the same direction as gravity. So it's meters per second. And SY is 46 meters, okay? Now, if you have 3 of these things, you can work out the rest, okay? So here we want to work out the time of flight because the distance it travels will be this multiplied by the time it was in the air for, okay? Because remember, horizontal distance, because there's no acceleration horizontally, is your initial horizontal velocity, or just a horizontal velocity, times the time of flight. So if we can work that out, we can work this out, which is the question we're getting asked, okay? So here, we pretty much can choose between our Suvat equation. So I would probably choose this one, S equals ut plus a half gt squared. Because here, my u is going to be 0, so my formula would simplify this. Sy equals a half gt squared, okay? I know what that is. I can work out the rest, okay? So 46 equals a half 9.8 t squared. If you want, you can put that in your calculator and solve n, but here I'll just go, so 46 divided by a half times 9.8, and then square root that, okay? Now here, this will give you approximately, I think, about 3 seconds. So here, if your time of flight is 3, so your horizontal distance, so USX, will be 25 times by 3. So that's going to give you, what, about 77 or 75, 25 times 3. So that gives you 75. So the approximate answer would probably be A, 77 meters, okay? So that would be the distance it travels here, 77 meters, okay? Again, this question here has a lot of working relatively, considering it's only 1 mark, okay? This would be better as a short response, but it's quite alright, okay? Alright, so question 9. So we're only going up to question 10 in this video just because it will be extremely long because there is 20 multiple choice. Select the list containing the 6 type of quarks. So here you got to remember your table. So up, down, charm, strange, top, bottom are your quarks, okay? So you've got to look for the list that has all those ones there. In, out, those aren't quarks. That one's not correct. Right, left, that's not correct. Up, down, charm, strange, top, bottom, that's the correct one. Pretty easy, as long as you remember this table here. Alright, question 10. The force that quarks experience that leptons do not, okay? So, a quark is what is comprised of a proton and a neutron. So, we're talking about inside pretty much the nucleus of it, okay? Most of the time, or inside pretty much proton and neutron. Leptons are like electrons, so they orbit around the nucleus. So the force that leptons don't experience but quarks will experience will be the strong force, okay? And that's pretty much just something you have to learn, unfortunately. There is no real overall like problem solving with the standard model. It's just know this stuff pretty much, okay? Right, well that'll be it for part 1. I'll be doing part 2, which will be answering the rest of these questions very shortly. But if you have any questions about the first 10 questions we did here, leave something in the comments and I'll try my best to answer it. But I'll see you in the next one.